Hello everybody. Today we are looking at the kinetic molecular theory, which is basically why things are solid, liquid, and gas at the molecule level. So the kinetic molecular theory, as the name implies, takes from the concept of kinetics, which means to move. Now the molecule obviously is the molecule, atoms, and particles. And kinetic molecular theory looks at why is it that solids are solid, liquids are liquids, and gas are gas. And effectively, the idea is that those three states of matter are all based on motion. As you can see in the picture above, motion is what creates a solid. The molecules are close together, but they are moving. A liquid, when you add energy, the molecules start to move faster. And when they start to move faster, they don't really hold well together. Once you break some of their connections, they start to flow, just like water. And if you increase that temperature or energy even higher, you can turn them into a gas, which means they are moving very far apart from each other and don't want to connect at all. Now, how does it do this? Think of molecules like a pool ball. If you hit them hard enough, what they'll do is they'll spread out in random directions. Notice down here, you can actually see that the pool balls, when you hit them hard enough, actually go in every single direction. But not all of them are moving at the same speed. Some are moving faster and some are moving slower. The reason for this is very interesting. This is called the conservation of energy. The energy that the cue, the white ball at the beginning, has is being distributed evenly amongst all of the balls. What you end up seeing is the sum of all the energy going into those billiard balls and going out in every possible direction. The direction is random, but it saves all the energy. Not unlike what you see here. This is basically sound waves moving through the air. Sound, being a form of energy, pushes molecules through the air. Now each molecule hits another molecule, which then hits another molecule and hits another molecule, exactly like waves in the ocean. Now if you watch the little red dots, you'll actually notice they don't really move very much. They just kind of hit the one before them. This is why in space, where there is no molecules, you cannot hear any sound at all. Now the same principles move and operate within molecules that are more dense. Air, being a gas, doesn't allow the sound to travel far, but when we put it into a solid, that makes a whole difference. As you can see here, we have a question. What happens if you're cooking marshmallows on a metal rod versus a glass rod? Which one will eventually burn their hand first? It's interesting. Both are solids. Both could burn, and anybody who's touched a hot glass rod or a hot metal rod knows both of them burn equally painfully. So which one would go faster? So make your guess now, and we're going to see in just a second. Ready? Let's go. And as you can see, the metal rod is already red. The glass rod barely moved. Now we know fire doesn't have to burn things that are right nearby it. Here is a picture of cars that are burning on a highway. They're right next to each other, and they're not really being touched by flame, yet the cars next to them are bursting into flame. The heat from the cars is enough to cause fire in another vehicle. And what you see in the current picture is what happens when the light from the sun is concentrated off of a skyscraper onto a car, effectively melting the car. This highlights the point that energy can be conserved and even converted. Light can be turned into heat. Radiant heat from fire can be turned into flame, combustion, and so on and so forth. We do the same thing with sound. Sound can be turned into a form of heat production. We can turn radiation into heat, like what we do in a microwave. That same microwave also can convert electricity into radiation, which then gets converted into heat in your food. Our most potent source of energy is, as you can guess it, the sun. That sun produces a ton of energy all the time, and we harness it. We get light from it, we get heat, we also get radiation. Anybody heard of UVA and UVB that gives us sunburns? All of this is happening all at the same time. Now, this does drive a lot of other energy sources on our planet, as you can see right here. All of those things are us harnessing, converting, taking energy, and changing it into different forms of usable energy. So, stay tuned for the next topic on radiative, conductive, and convection energy, as well as a lot more information on conductive materials as well as insulating materials, to take advantage of the fact that energy comes down, and if we don't trap it, we have nowhere to go with it. So, see you then.